Hello. So my name is Matthew Mitchell. I'm a student at GIST 99 here at the University of Arizona, and I'll be presenting on the optimizing transformer management, GIS analysts, and Esri tools field deployment. So a little background, I'm currently working at Navajo Tribal Utility Authority, and as a utility, the distribution supply chain affected us greatly. So this increased the transformer cost from like, $300 or $400 up to 3 or 4 thousand for the same product. Lead times went from the end of the month, if we ordered, 30 days, out to 18 months, and we're still waiting on the orders that we put in before COVID in some cases. Also, N2A needed to identify transformers. So we needed to identify idle transformers in the field to optimize how to use transformers that we have. And we refer to it as hanging inventory because it's in the field and it's just hanging out there. So the issue was there was no way to officially track this existing transformer system. How do we track process and find out where the transformers are essentially? And before, the process was just very manual for the districts out in for us to find it, right? So someone would report an idle transformer, and then it may or may not be pulled out, so it's very error prone, right? It's all hearsay, like, hey, there's a transformer out there, and then they would eventually take it down. This caused issues with the staff. When the staff get busy, there's workflows that didn't exist, so it would be forgotten about, right? And then also we had to figure out how to do a scalable solution because we do cover N2A covers the entire Navajo Nation, which is size of 27,000 square miles. So we had to locate the idle transformers, um, and we use GIS tools to do this. We deployed tablets out in the field for our guys to identify tablets. This is our identified idle transformers. So this enabled us to verify, see pictures, right? These are pictures that you see here of an idle transformer in the field. And this just improved our resources, of that already existed, that we were able to reuse what exists and just help really streamline our operations out in the field. So, I mean, in the picture here, we can see the size of Navajo Nation. Right there's the four corners. And, like I mentioned earlier, we do cover 27,000 square miles of area. So a lot of our areas are very remote. And this presented a complexity of like how do we give these guys and the data a way to inspect the transformers, how do we find the transformers, and then how do we so just a lot of logistical demand of how do we streamline our systems. So we came in looking at two different data systems really. GIS data, which we can see in the map here, are in these pictures here, was coming out of our enterprise GIS system. And the same picture is the AMI, automatic meter infrastructure. So that works with our billing system and pulling meter reads, and that's how we build customers. So there's a couple different methods that we did. We did a lot of Python automation to create the relationships between the transformer and meters, a lot of data cleanup to make sure that the transformers were correct. We created a dashboard, and then we used approaching the remoteness of our territory. How do we do on-prem and off-prem synchronization? So the first thing we had to do was develop the relationship, right? How do we identify idle transformers? Use Python scripts to create the relationship between the transformer and the meter. We can see in the picture there, the transformer is a triangle and the meter is that highlighted icon. So we did was just, use the secondary service lines, which is just a polyline, and select everything down line. Then we select the relationship, and that allowed us to establish that link between the transformer and meters. So once that was done, then we had to cross-reference the data, right, between SAP, which is our counting program, AMI system, and GIS. So here in this picture, we can see you have the yellow, which is the GIS meters. And you have the kind of the greenish one, which is the AMI meters. So we had to cross-reference those. Once we established a relationship, then we're able to say, okay, select everything within. Initially we did 10 meters because there was just so much false data we had. And this, so we found meters that are mismapped. We updated meters in both GIS and AMI, and this helped us reduce errors. So there's just a lot of data validation that we do in the office before we would do field work. So while we're doing the field work, we found out that okay, on-prem doesn't work. So we moved to AGOL for our field guys, and we kind of did a costly analysis for ourselves. On-prem is more secured, but it's also more costly because we got to run our servers. On-prem AGOL allows us to scale up, right? We got the flexibility of cloud, so they can sync their data wherever as long as the internet connection. On-prem allowed us to share our data more publicly. That way we didn't have to have users log in. Some of our data sets, especially our electric lines, anyone that has connection to the on-prem servers can upload the data. So like I mentioned earlier, AGOL is essentially all of the field data collection. All of our survey 1, 2, 3s run through that. And then field maps, all of that's AGOL. And then this really worked, this hybrid system where AGOL is for field work, and then on office, connected to the intranet is really for on-prem. So how did we identify these transformers after we did the analytics? Really, the field crews helped us a lot. We deployed well over 100 tablets. I think we're up to 200 now. And then so one of the things was how do we download the entire data set for our area? We solved that by creating a map pack and side loading that onto the tablets, which is about 60 gigabytes. So that really allows them to see imagery of what it looks like. Then we have Survey 1, 2, 3 for inspections, field maps for more of the planning and seeing where the assets are. And then once they get to that location, they would click on Survey 1, 2, 3 on the hyperlink from field maps in the Survey 1, 2, 3 and open up the Survey 1, 2, 3, which allowed us to control where we take pictures, how we take pictures, and that's really what we have, right? A picture tells 1,000 words. So we're able to, if someone had questions on what was in the field, we had pictures to back up essentially what's collected in the field. This really helps streamline because they won't have to call the field crews, they wouldn't have to revisit that location because we had pictures, we had questions, and answers at those, and geo tag locations. So one of the things we do was go out and staff our training, train our field staff. So we had hands-on practice sessions. We had to tailor our workflows from guys who grew up with technology to the older staff who have a hard time using a flip phone. So we had to really go through, into the course introductory GIS concepts. How do we train people, the on-premise practice with the field maps, the Survey 1, 2, 3. Initially, when this started, there was a lot of idle transformers, so we were able to almost step outside the office in some cases and just show them how to do the inspections right then and there. So this really boosts efficiency because one, it wasn't GIS or AMI staff, the operations system staff doing it. It was the field crews who are subject matter experts and they know what their stuff is. So part of the data collection, right, was field maps for planning so they can visualize where they need to go. And then they can prepare their offline maps, meaning they download where they're working or they're syncing where they're working. And then field data collection, Survey 1, 2, 3 are some of the more simpler stuff. We just used field maps, forms, right, built into the field maps. Then they submit the collected data, and then data validation and cleanup. So that really came back to our GIS guys, right? Different attributes that need to be updated to match what was in the field to help start moving towards the digital twin that we're looking for. Also, updating the dashboard. That's a big thing that we noticed. The dashboard creation, we developed to kind of build a top overview to see how the projects move along time, right? And this really allowed us to have real time updates in the field. And then the dashboard allows the districts, we have 7 districts spread throughout our area, to view and really help narrow down where they need additional work, additional resources. And it is a dashboard, so it is an interactive map. They can scroll and move to the areas, and it's really helped management, kind of like, we have X amount of transformers that were inspected. Now these ones are awaiting some type of action on them. So this is the results from our massive endeavor, right? So we've identified over 1,500 idle transformers. So if we put that in figures, like how much does it cost per transformer? We're looking about 5 to 6 million currently in just transformer costs alone, right? That doesn't include the active meters that are mismapped, security lights only that billing might not be charging, idle energized. We can see that table. I'm just going down. The idle energized, right? There's something on transformers called no load loss, meaning when the transformer is connected to the grid, it's drawing power. So just that alone, we figured about 50,000 a year in savings when we de-energize those transformers. Idle de-energize, I mean, that's what they are. They're just sitting there hanging out in the field. No transformers. So this really helped the GIS side clean up our data. The no transformers, we had to remove those transformers from the GIS to start matching those on the field. That's just, streamlining the data from the field into us, so to help build operation efficiency, so that way we know where transformers are, where they're not, and start building out our digital twin. And then part of it was like, how do we update people on the current status? So we built this emailer that just goes out, once a week and sends out these inspections for the different districts, right? We see Chinle, Crown Point, Delcon. So just to name a few of the districts with different attributes, right? So this really helped draw the attention of management, right? To start, one, build like a competition between the different districts, like, hey, we've done this and then we're falling behind. And 2, to kind of see a general overview of how the entire operation is. So in conclusion, right, I just wanna say, like, the GIS really helped NTUA with this endeavor, because we were able to build the relationship between the transformer and the meter, and that never happened before. So now we're able to run analytics on that, right? How many what's the load on these transformers now, and all that. So the scalable framework was really interesting to see the field guys buy into this, because like they're like, oh man, we love having field maps, because we're able to see our system, right? So this is the first time they're able to carry around the electric, the gas, the data, all the data in their hand and have it right there, right? So this helped improve the operations, right? Because if a lineman goes to another district, they don't know the district, but now they have at least information. And then we can see on the pie chart there, just kind of a broad overview of idle de-energize. Once we remove the meter, once we remove the transformers that were removed in the field from that equation, we can see 20% of those transformers that do exist in the field are technically de-energized, meaning they're just sitting out there. So, and then we're trying to make our utility more, what's the word, a digital twin, so that way we can future ready our systems in GIS and start running more conclusive analytics on it, and prepare utility in the future. So I do want to acknowledge the NTUA team, the GIS, the field operations team was very instrumental with all the field crews, do the inspections for us, able to get this data back, and further NTUA's initiative to provide power to our people. And then the university and the guidance provided to to, as I was going through my 909 capstone, I had questions and they were able to answer. And then just collaborative success, adding 2A for this successful project. Okay, questions and discussion?